next module of our chapter called Magnetism. In this particular module, we'll be learning Curie's law, right students? So let us start. What is Curie's law? Now, in 1895, Marie Curie discovered this particular law experimentally, and this particular law is only applicable to the paramagnetic substances. Now, what are paramagnetic substances? What are their behavior, right? What are the different examples of paramagnetic substances? That we'll be learning in the forthcoming module, right? Now, he discovered this particular law for the paramagnetic substances and he converted it in the form of statement. Now, let us see the statement for Curie's law. He stated that magnetization of a paramagnetic sample. Now we have already learned what is magnetization. Magnetization is the ability to get magnetized. So magnetization of a paramagnetic sample is directly proportional to the external magnetic field. So therefore I can write mathematically as mz directly proportional to B external, right? This is the first part of the statement, right? Now second part of the statement says that this magnetization is inversely proportional to the absolute temperature. Now students, what is absolute temperature? Whenever the temperature is measured in Kelvin, right? Whenever temperature is measured in Kelvin, then we call it as absolute temperature. So what can I write? From here I can write mz directly proportional to 1 by T. Right? Now combining these two statements, what will I get? I'll get mz directly proportional to B external upon T. Right? Now I'll remove this proportionality sign and I'll introduce a constant. What will I get? I'll get mz is equal to capital C times B external upon T. And what is C? C is Curie's constant, and I'll name this above equation as equation number 1. Right? Now in the previous modules, we have learned different formulas for external magnetic field. What was the formula for external magnetic field? It was given by B external is equal to mu naught into H. And what is H? H is the magnetic intensity. Now what do you mean by magnetic intensity? It is the ability of the field to magnetize. And what is magnetization? Magnetization is the ability of the material to get magnetized, right? So I'll be putting this relation in equation number 1. What will I get? I'll get mz is equal to capital C into mu naught into capital H upon T, right? Now let us move further. Let this last expression be expression number 2, right? Now students, also we have learned relation between mz and H. What was the relation? Relation was mz is equal to xi m into capital H. And what is capital H? Capital H is magnetic intensity. Xi m is magnetic susceptibility. So I'll be putting this relation in equation number 2. So let's see what we get. We get xi m into capital H. It is equal to C into mu naught into capital H upon capital T. Now see this equation, right? Carefully observe. Which term is in common? Yes, capital H is in common, right? So I can cancel out this H. So what will I get? I'll get xi m is equal to C into mu naught upon capital T. Now see this section, C into mu naught, right? What is C? C is Curie's constant, right? What is mu naught? Mu naught is permeability of free space. So C is Curie's constant, mu naught is permeability of free space. So both of them are constant. So I can say that their product, which is C into mu naught, will also be constant. So I'll name it as capital K. So what will I get? I'll get xi m is equal to capital K upon T. And from this, I can write xi m is inversely proportional to absolute temperature. Now student, this relation is very important, right? So what we have learned? We have learned that for a paramagnetic substances, magnetic susceptibility is inversely proportional to absolute temperature, right? What we have learned? We have learned that magnetic susceptibility for a paramagnetic substance is inversely proportional to absolute temperature. So student, this is the final step for the Curie's law, or rather this is the final conclusion that we get from the Curie's law, right? Now let us summarize what we have learned in this particular law. Now first thing that we learned is mz is directly proportional to external magnetic field. Second statement, mz is directly proportional to 1 by T or inversely proportional to T, right? Combining these two statements, we got mz directly proportional to B external upon T, and therefore I get mz is equal to capital C into B external upon T. Now we also know the relation. What relation? B external is equal to mu naught H and mz is equal to xi m into H. Now when we put this relation in the last part, right, what we got? We got xi m directly proportional to 1 by T. Now using this last relation, see this carefully, xi m directly proportional to 1 by T. Now we can write the relation of magnetic susceptibilities for two different temperatures. So at two different temperatures T1 and T2, I can write xi1 upon xi2, it is equal to T2 upon T1. Now student, take care. On the right hand side there is T2 upon T1 and on the left hand side there is xi1 upon xi2. Now why such kind of relation? Because they are inversely proportional. See this last step. They are inversely proportional. Now student, this relation will be using at many places in numericals. At the same time we'll be using this relation in entrance part as well, right? So take care of this particular section properly. Till then, thank you.